What's up, everybody? It's Dan from Sage Math Tutoring, and here are the video. A couple tricky problems that my student brought to me that I actually, at least this first one, we did it right, but for some reason, maybe we entered it in the calculator wrong or something, but it ended up giving us not exactly the right answer in the calculator. But for my student watching, just know that actually everything we did was good. Um, We did it right. There must have just been some like minor detail with how I entered it in the calculator, maybe that caused the number to be like slightly off. Okay. But I want to nonetheless go over this problem again. That way my student understands, exactly what's going on with it. And also there's another problem after this that we're going to take a look at. So let's look at this. Chris and Linda warm up in the outfield by tossing softballs to each other. Suppose both toss the ball at the same time from the same height as illustrated in the figure. Find the minimum distance between the two balls and when this minimum distance occurs. Okay, so that actually is two missions. Find the minimum distance between the two balls and when the minimum distance occurs. Okay. So for my student watching, once again, we did everything correctly. So everything I'm about to say should seem pretty familiar. The bottom line is we will need a way of understanding sort of the X component as it pertains to Linda, and we will need a way of understanding the X component as it pertains to Chris, and then the Y components for each as well. So focusing on Linda, so we have X sub t is most definitely going to equal that sort of initial velocity, which is 45, times cosine of 44, and that's t right there. The y component for Linda would take into account the fact that we're sort of starting at this 5-foot elevation. So we start there. And then we add on top of that the 45 sine 44 degrees t. And then we have to subtract gravity from that situation. Okay. Right. Is there an issue with any of that? No. So for my student watching, just know that I always like to kind of put the starting point as the constant in the beginning of the expression. I think maybe your teacher is putting it at the end, but that's just my style. Once again, I always like to think about the starting point, or in this case, it's like the starting height, right? Because we're dealing with y. Now, let's be very clear. This has to do with Linda. Now, when it comes to Chris, I kind of emphasize that whole starting position thing because that actually does apply to Chris because we can imagine that Linda is starting at, the origin or something, whereas Chris is starting horizontally to the right of that 78 units. So I'm actually going to put Chris's starting horizontal position as a constant in the beginning. Now, for my student watching, notice please how this is a positive 78. That means that his starting position is 78 units to the right in the positive direction. However, the horizontal movement of the ball, like, yeah, we know it's going up at a slant, but the horizontal component is moving to the left. So that needs to be denoted by the fact that we're subtracting right now cosine, the, what is it, 41 cosine of whatever his angle is, t. Okay. So this minus action means that the ball is moving horizontally to the left. Now, as it pertains to the y component, my student watching, I think you understand the quote unquote starting position as it pertains to the y. The height is still 5, right? And actually, it's going to be the same because the ball goes up and then it goes down, right? So it's still this kind of positively going up, but then gravity takes over and brings it down. So this is going to be very much reminiscent of Linda's y component, except it's 41 sine, and then the angle is 39. t, but then we have to take gravity into account, which is 16t squared. So this is Chris's information. Okay. So it's the case that the distance formula is this. And in a sense, we're going to be using the distance formula because the reality is it's just going to be the same thing. Only as it pertains to the x components, it's going to be the x component of Chris minus the x component of Linda, and then the y component of Chris minus the y component of Linda. And we want to minimize this. Now, hopefully, my student watching understands. You can minimize this distance by minimizing this whole other side, of course, right? And you can minimize this whole other side by minimizing the thing that's under the radical, right? Also known as the radicand. So let's actually have our attention drawn to the radicand by squaring both sides. That would give us a d squared. And that is going to be just this, right? All of this stuff. And you can acknowledge, hopefully, that upon putting all of this information into the calculator, it will actually be a parabola, okay? And because it's quadratic, and the parabola might look something like this. I don't know. But the so-called y-axis would really be a d squared, and the so-called x-axis would be a t. Now, when we enter everything into the calculator, we are going to use x here, okay? But just know that this x-axis does indeed represent time, okay? So, and importantly, this vertex corresponds with that very special value of t where the sort of distance is minimized. Okay, the distance between the balls is minimized. Now, this is d squared. Now, you could actually find the y coordinate of the vertex and take the square root of it, and that will give you the minimum distance. Okay, so that's something to take into account. But you could also acknowledge that upon looking at the vertex, whatever that x coordinate is, that is the time associated with the distance between the balls being minimized. Okay. So that's stuff to acknowledge. And that's also descriptive of our game plan. Our game plan is to put this into the calculator, graph the parabola, and then look at the vertex. Okay. Now, for my student watching, as of right now, I am weak when it comes to knowing fancy moves with the calculator. There might be a really smart way that I don't know yet about how to enter this in a way that's not as crazy as what I'm about to show you. I'm going to say ask your teacher if there are any shortcuts when it comes to entering this into the calculator. For now, I'm going to enter this straight as it is. Okay. Now, let's be very clear. When we do that in the calculator, it's going to be the x associated with Chris, which is this entire thing right here. Okay. Minus the x associated with Linda, which is this entire thing right here. And it's going to be that thing squared. And then it's going to be plus um, the y associated with Chris minus the y associated with Linda. Now, let's be very clear. The y associated with Linda is this part here. Now, if you were to subtract the black from the red, because this is the y associated with Chris, hopefully you see that the fives would cancel out and the 16t squares would cancel out. So it would really just be this red thing minus this red thing. So let's only do that. So we have the 41 sine whatever, and that's going to be minus this 45 sine. And then it's going to be that squared. Okay, so that's what I'm going to put it in the calculator. So when I throw that in the calculator, this is what it looks like right here. Okay, I just threw it all in one line. Once again, there could be some savvy way of going about this, but I'm just going to be very straightforward with it. And then it would turn into this parabola when you try to graph it. And as you can see, the minimum is right there. And after inspecting the minimum, we have an X value, and that's associated with the time it takes for the distance between the balls to be minimized. So that in and of itself is one of the answers to the questions that they're asking, namely the yellow question, when this minimum distance occurs. Well, that's the X value. Now, this Y value, once again, you have to be careful. We plugged in an equation for D squared. So that Y value here is associated with D squared. So in order to get the actual D, in order to get the actual distance, you would have to take the square root of that. And the square root of 43.6 is around 6.6. Okay, so that's going to be the answer to that one. That is all I have time for right now. Hopefully that makes sense to my students. This is correct. In fact, the way that we were doing it was correct. The only thing I could say is be on the lookout and or ask your teacher if there's a better way of entering this so that you don't have to actually plug all of this in and be very meticulous with parentheses and so on. Okay, so that's what I would ask. But anyway, good luck to my student, and hopefully it was helpful, and I will talk to everyone later. Bye.